Arriving at the wire mills, the rods are unloaded by these efficient petrol-electric cranes, which deliver the rods to the cleaning house. The rods are first cleaned in hot acid to remove any scale. This hosing washes away all acid and loose scale, and the rods are now dipped in hot live water and dried in ovens, ready for drawing into wire. Here we see the curled rods passing through hard steel dies at 450 feet per minute. This process reduces the material to a true round wire of the heavier sizes. These are the fine wire drawing machines, on which portion of the wire just seen is continuously drawn through several dies on each machine to the finer sizes required for wire netting. Imagine the capacity, 60,000 miles of this fine wire a week. Now for wire netting. First, the wire is prepared in spirals for the shuttles of the looms which weave wire netting in sizes from a half-inch to 4-inch mesh. And this is the immense weaving loom room. Here we see the actual weaving of rabbit netting and the woven material being coiled into rolls. The combined capacity of the weaving looms is over 1,000 miles a week, more than Australia's total requirements. Here is the final process, that of galvanizing. After being cleaned in acid, the netting passes through these baths of molten zinc and is wound into the finished roll, ready for the market. Turning now to fencing wires. They are here galvanized with a coating of molten zinc. First, the wire passes through this bath of red hot lead to soften it to the required temper, then cleaned in acid, coated with zinc, and finally wound into coils of fence wire. Here are more interesting machines, making the various types of barbed wire. Watch the barbs being put onto the line wires in this slow motion. The machines really do it at 300 barbs a minute. The wires are then twisted together and wound onto the wooden reels. This wonderful machine is weaving wire into finished field fence. Watch it securely twist the droppers into place. The whole fence in one piece. And now, the successor to the wooden fence post. Hundreds of thousands of these steel posts are used to make fire and ant-proof fences. Wonderfully strong and yet light to handle and easy to erect. And so the products of the Australian wire manufacturers, produced on the most efficient machinery and equal in quality to the world's best, lead the best from Walkman by rail for every part of the Commonwealth and New Zealand. Another giant industry is located in this building, the production of wire ropes. The steel wire is received from the drawing mills into the rope works, where it is carefully inspected, weighed, and placed in the wire store, which accommodates and usually holds 1,000 tons of wire. The manufacture of wire ropes commences with the issue of wire to the testing house, where the individual wires are tested. Here you see the test for toughness, the wire being gripped at one end and rotated at the other until fracture. The tensile test records the strength of the material, and from the data logged, the strength of the wire rope is computed. The tested wires now pass to the winding machines and are wound on steel bobbins under slight but even tension. These bobbins of wire are placed in stranding machines, and in the high-speed type of machine are fixed in cradles slung in line within a long tube. The wires are laid along the tube to the nose of the machine through a lay plate to the dies, and as the tube revolves, the wire strand is formed. It is immediately coated with petroleum jelly, which acts as a protective lubricant. In the other type of stranding machinery, where the larger sizes of wire are stranded, the bobbins are loaded into flyers grouped together in cage formation. The wires are led through the lay plate to the stranding dies, and as the machine revolves, the strand is formed. And here is the process in slow motion. The strand is measured as it is made and wound on steel bobbins. Nearly all wire ropes contain a center core or heart of fiber, and here you see these cores being impregnated with molten petroleum jelly, which will provide for the internal lubrication of the wire rope. The final process, again shown to you in slow motion, is the closing of 6 strands, each of which, in the rope now being completed, contains 17 wires. These wire strands converge and close around the hemp cord, the dies exerting great pressure, which molds the rope into the correct size. Lubricant is pumped in at the converging point, as you see, and the completed rope wound onto a wooden reel. This particular rope is 5 inches in circumference, has a breaking strain of 100 tons, and will be used for mine haulage. A portion of each wire rope is then placed in the tensile testing machine, where strain is gradually applied until the rope breaks. Wire ropes for elevators are subjected to a fatigue test on this machine, where the to and fro movement over very small pulleys causes a breakup, thus providing an accurate forecast of life when applied to its job on an elevator. And here you see the ropes being packed for dispatch throughout the Commonwealth. Especially in the production of haulage and winding ropes for use in mines, the Australian Wire Rope Works Limited have succeeded in making a product equal to the best imported. To Lysart's Newcastle Works are brought the sheet bars from the continuous mill. The bars are cut by these big shears into the correct lengths for rolling, and then stacked in cradles. They are then charged in pairs into the furnace. On emerging at the rolling temperature, they enter the breaking down mills. The bars are fed in by the roller and then passed back over the top of the rolls, sufficient passes being given to reduce them to the required thickness. And here we see the packs. An electrically operated table heaves over the packs, and the finishing rolls complete the rolling. Conveyors carry the packs of sheets to these shears, which square and cut them with precision to the correct lengths and widths, and prepare the sheets for cold rolling. Packed in 10 to 15 ton lots, the sheets pass through the continuous annealing furnaces for 8 hours at high temperature. In the steaming atmosphere of the pickling house, acid removes the scale. The pickled sheets pass through the flux into a pot of molten metal heated by gas. Here they obtain a bright and even coat of metal and pass through a cooler and dryer, finally reaching the inspector, who carefully examines each sheet. Plain sheets must be dead flat, and so they are stretched in a powerful flattening machine, which removes all traces of buckle. Only after very careful inspection are sheets deemed satisfactory for branding. This is done in this machine, which automatically brands each sheet. And, having branded them, stacks them neatly so that they can be easily handled for further operations. In these great rollers, the sheets are corrugated to a fixed standard, and the accuracy of the machine ensures that there shall be no deviation in the corrugations. Other machines are employed to deal with small corrugations and heavy gauges. The final process consists of weighing the finished product into lots of approximately 10 hundredweights each and packing them into the wooden cases. Securely nailed and branded, the cases are now ready for dispatch to all parts of the Commonwealth. This year, the works are capable of producing about 100,000 tons of finished sheets. And here you see a trainload of galvanized iron ready for shipment to other states. And so we finish our brief tour through another great and interesting works. At Mayfield, Newcastle, Stewart's and Lloyd's have the most modern tube plant in the world. Production commenced last year with a capacity of 55,000 tons annually in tubes from a quarter inch to 3 inches in diameter. Here is the scope for making the tubes, being received at the mill from the BHP. The coils of skelp are taken from store by travelling crane and fitted to an unreeler. From here, they are passed through a mangle to the flash welding machine. And here, the fore end of one coil is welded to the tail end of the preceding one. After this, the continuous strip moves into a reserve pit, from which it is drawn into the furnace, and gradually brought up to welding heat as it passes through. This furnace uses 1,000,000 cubic feet of gas per day, and the furnace temperature, gas and air mixtures are all regulated by this intricate battery of instruments. Leaving the furnace, the strip enters the welding mill, where it is formed and welded into a perfect tube. The red-hot tube is then cut to required length by a flying saw. These operations being controlled by an operator at the mill control stand. After sawing, the tubes are passed by conveyor to a cooling rack, and from there to this sizing and scaling mill. As the tube emerges, a jet of high-pressure water through it blows out all loose scale. This operation is performed automatically by the tube. After sizing, tubes are returned to further cooling racks, thoroughly examined, and passed to a milling machine, which removes the burr caused by the hot saw and prepares the end for screwing. Prior to being galvanized, tubes must be pickled by immersion in sulfuric acid. This is an automatic pickling machine capable of dealing with 2 5-ton loads simultaneously. The manufacture of sockets is an interesting operation. All sizes are made from the solid bar. Here, the larger size is being forged in mechanically operated forging machines. Observe the finished red-hot sockets in the container. Screwing of the sockets is performed on these 4-spindle automatic screwing machines, equipped with drilling and tapping fixtures and arranged with rotating tables, with loading station to facilitate operations. All tubes are tested to 700 pounds per square inch, and here you see the operation being performed on an automatic testing machine. Here, tubes are passing through an automatic screwing machine, which threads the ends perfectly and passes them over a cross-transporter to a coupling screwing-on machine, which is synchronized with the screwing machines. The finished tubes are then bundled, marked, weighed, and transported, and so to the mill warehouse for final examination before storing and dispatch to all parts of the Commonwealth. Stewart's and Lloyd's plant at Newcastle is an important part of their empire-wide organization, employing many hundreds of Australians and using an immense amount of Australian material. It ranks as one of the major secondary steel industries in this country. For the manufacture of rolled steel rings, specially shaped ingots of hard and tough steel are brought to the works of the Commonwealth Steel Company Limited, and after very careful inspection, they are lowered into a powerful machine. Here, the ingots are sliced into individual cheeses, each of the precise weight needed to make the finished tire or ring. The cheeses, which may weigh as much as 2,000 pounds, are heated in continuous furnaces and brought out at forging heat. The white-hot piece is transported to a steam hydraulic press. Here, steel hands take charge and center the cheese as the forging die comes down, exerting 2,000 tons. In this operation, each cheese is flattened into a disc shape and a hole is punched through the center. The tire is roughly formed and goes to the rolling mill to be formed accurately to contour and expanded to the size desired. Leaving the mill, the tires are given special toughening heat treatment and severe tests for resistance to wear and shock are undergone. This view is of a battery of boring and turning mills, machining tires to fine limits for assembly into wheel sets. Approximately 500,000 tires have been sent to work throughout the length and breadth of Australasia. All these products are made under rigid scientific control. The strength and ductility of the steels are proved in this machine. Resistance to shock is measured by the ISO test. Essential to research, the microscope is used to study structures in the steel and to control the thermal treatments. Steel for special forging ingots and steel castings is made in an electric furnace. Selected raw material is charged into the furnace to be refined and alloyed under laboratory control. Rapid chemical tests determine the removal of impurities and accuracy in composition. Overhead cranes bring a casting ladle into position to receive the molten metal, and as soon as physical and chemical conditions are perfect, the furnace is tapped. Sand molds for steel castings of infinite variety are prepared by skilled molders and filled with steel from the casting ladle. When cool, the castings are taken out of the mold and go on to the dressing department. Oxyacetylene torches cut off the feeding heads and runners. The castings are shot blasted and then ground with high-speed wheels. After heat treatment, each casting is inspected and approved in dimensions and quality before machining or shipment for use in railways, ships, mines, and every branch of engineering. Railway wheel centers are bored and turned in one setting on this composite machine tool and go to the assembly shop where the wheel sets are put together. From the furnace, hot billets are fed continuously to a hammer where railway axles are drawn to shape. Heavy work is forged by this hydraulic press, and then later on, modern machine tools turn and grind the forgings to finished articles. You have seen a few highlights of another great Australian industry, which is forging ahead, maintaining high standards of quality and sending its products throughout the Commonwealth and the surrounding territories.